Okay, so it's asking us on this question to describe the long run behavior of this function. So how do we describe the long run behavior of that function? Well, what we basically need to do is, and when it says long run behavior, what does it mean? It means as x goes to negative infinity and as x goes to positive infinity. In other words, if we were to graph this thing, this function would, I don't know, go up and down or whatever. But the question is, oh, whoops, that's not what I wanted. The graph will go up and down or whatever. But what will it do in the long? Will it go up, 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 up? That would be positive infinity in the long run. Or maybe the graph will go blah, 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 and it'll go down, 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 down. That would be negative infinity. So the long run means as you go to the right forever. So that's what we mean, long run. So by the long run, we mean as you go to the right forever. Well, that's the long, that's not entirely the truth. That's the long run as x goes to positive infinity. And then the other direction, maybe this graph goes up to positive infinity that way, and this graph goes again down to infinity that way. So that's so that's the other direction. So this is the long run as x goes to negative infinity, that direction. So on the x-axis, you can go to the right forever. So long run x goes to positive infinity is right, is forever right. And negative infinity is forever left. So as the graph goes forever right or forever left, what does it do? Okay, well, how do we figure that out? Well, what we do, it's only the most powerful term that's going to determine that. So in other words, all you have to do is plug x equals, just plug x into the highest power term only, into the highest power term only, which is this guy. He's the most powerful. He's got the biggest power on him. Is this making sense? It's only the most powerful term. Why? Because he's more powerful than the other terms. He's going to determine the answer. He's going to make it the case. Let me get this kind of out of the way here. He's going to tell you what's going to happen in the long run, because this guy will dominate the other terms. He's more powerful. So let's plug in negative infinity first off, and let's see what we get, right? This first one is x is negative infinity. So we have f. F, by the way, is y. Remember, f function values are the same as y values. Y, the height, in other words, is minus 2. Plug in x, negative infinity. Didn't have enough room there. To the 9th power. And don't even worry about the other terms. They're unimportant because they're less powerful. They will not ultimately determine. It's only the most powerful term that will dominate and tell you what will happen in the long run. The other terms matter in the short run. They'll have an effect on the graph in the short run, but only the most powerful term will determine what happens in the long run. Anyway, what does this equal? Is it positive or negative? It's positive. Why? Because there's 10 negative signs. Do you see that? 1 negative, and this is 9 negatives. So that's 10 negatives, which is positive. See what I'm saying? This is a 9th power. 9 negative infinities, and then a negative 2. So that gives you 1 negative, 9 more, 10 negatives altogether, positive. And then what about this other part down here? What about when we plug in regular infinity? Well, same thing. Y equals minus 2. Plug in regular infinity to the 9. Okay. that's going to be negative infinity because it's only one negative. It's only one negative, the negative in the very front. So the first answer was positive infinity. The second answer is negative infinity. The graph's going down forever. And so there we go. So what have we learned about this? Like, if we were to graph this thing, what does this graph do? Well, as you go negative infinity means left, because remember, this is the x-axis. So this is the negative infinity on the x-axis. As x goes to negative, as you go left forever, this goes up. So our graph is going to go up, up, up to the left. And as you go to positive infinity, that's over here, positive infinity, this is right. As you go right forever, the graph's going down, down to negative infinity. Does that make sense? So that's generally what that function is going to look like in the graph. It's going up to the left. How do you know? Because as x goes to left forever, negative infinity, the function goes up, positive infinity, the f, the y, the height. And as x goes to positive infinity to the right, the y, the function goes down to negative infinity, down forever. There we go.